Hi, I'm Colin Walls and I'm here once again to talk about embedded software. Today I want to think about memory in embedded systems. Now, we all know about memory. There's two kinds, there's read-only memory and there's random access memory. Nowadays we tend to do everything in random access memory, simply because it's a whole lot faster than the read-only variety that we used in years gone by, and is therefore quite convenient. The downside, maybe it's a downside, of RAM is that when you turn the power off, the data goes away. This was not always the way with computers. Going back many years, standard memory architectures used devices that retained the data even when you took off the power. But anyway, that was then, this is now. Nowadays, we lose that data. Now, sometimes it's convenient to have some memory that will retain data, even through power failure. So this might be for setup information, configuration information, that kind of stuff. Depends on the application. You could keep absolutely everything in that kind of memory if it suited you. And of course we do keep code in flash memory, and we could keep data there in the same fashion. And that's only one of the couple of kinds of non-volatile RAM, NVRAM, that we could use. So it's flash, or you could have ordinary RAM which has a battery which is maintaining the data integrity. So that's all fine. The problem is that when the software starts up, it will want to read the data out of the non-volatile RAM, but how does it know the data is valid? How does it know that the RAM isn't just full of garbage and it needs to be initialized? Well, that's a good question. It would know if we thought about it carefully, and the simple approach is to put in a known sequence of data into the non-volatile RAM, which we call a signature, and the software reads the signature and therefore knows that the non-volatile RAM is, the data is set up in some way. So what would RAM look like when you first powered it up? So if you've got some non-volatile RAM that hasn't been initialized, what would it contain? There are four possibilities. It could just contain a random sequence of bits. It might contain all zeros, it might contain all ones, or it might contain some kind of regular pattern. We can't predict any of this. It depends on the way the hardware is designed. And certainly we shouldn't make any assumptions about it. That would be very foolish. So what do we do about a signature? What could a signature look like which we would recognize as being different to one of these patterns? Well, my suggestion is we have a 4-byte sequence. So it's 00, FF, AA and 55. Now that represents all the bits clear, all the bits set, alternate bits, and alternate bits again the other way. Now this is a 32-bit value overall, so the chances of this occurring randomly is 4 billion to 1. So it's a pretty good chance that if this signature is held correctly, then we can be sure the non-volatile RAM has been initialized. Now the other thing we should do is maintain an integrity check on the data, so that we can be sure the data in the non-volatile RAM is okay once we've figured out that it appears to be initialized. And this can be done with a checksum or a CRC code or some other kinds of self-checking within the data. So this means that when the software starts up, when it's powered up, it goes through an initialization sequence. It will first of all check the signature, and if it's not valid, it would initialize the non-volatile RAM. If it is valid, it would then check the data's CRC or checksum or whatever, and if that's invalid, it would initialize the non-volatile RAM. Otherwise, it would assume it contains sensible data and carry on and use it. That's a brief introduction to the idea of using NVRAM. When you start addressing the memory cells from then onwards, you can handle them like ordinary memory, although you would have to bear in mind that the checksum or the CRC would need to be updated from time to time, and that's something which the software would need to take care of. So you need to write access routines for the memory which look after that for you. It could be done very neatly in C++, of course, but maybe that's a story for another day. So that's it. I hope you found this useful. I'll be back again before long talking about some other aspect of embedded software. But for now, goodbye.